Alright, here we're going to look at another projectile type problem, but this one is different in that the projectile is being fired from an elevated position. This time a rocket is launched at an angle of 50 degrees to the horizon at an initial speed of 48 meters per second. But this one is 50 meters above the ground below. So first we want to draw a picture to help us understand what this looks like. So this is our 50-meter cliff, and here is our projectile that is launched above. 48 meters per second at an angle of 50 degrees. So just like before, we want to find out what is the range of this rocket. Our first step is the same. Once again, v sub y is equal to our initial velocity of 48 meters per second times the sine of 50 degrees, which turns out to be 36.77 meters per second. And v sub x is also equal to our initial velocity, but in the x-plane we use cosine 50 degrees, which is 30.85 meters per second. So that part stays the same. Now the big difference in this problem is, in order to find the time, the problem is where we started and where we ended up are on two different level heights. So here we need to look at our coordinate system. So we're going to set up our coordinate system as so, and we're going to say this is the origin of my system. And we're going to use our old equation friend, x equals x naught plus v naught t plus 1/2 a t squared. Now we're finally going to use x naught in one of these problems to solve. Here, since we're setting up our coordinate system as being on top of the cliff is my origin, x naught is going to be 0. Now this is where it becomes really important in keeping track of our positive and negative signs. Since up here is going to be 0, the bottom of my cliff, x, is going to equal negative 50 meters. So we'll see what this looks like when we set it up. So x is negative 50 meters, so minus 50 meters is equal to 0 plus, now my initial velocity, I'm dealing with things that are in the y-plane, so I can only use my velocity in the y-plane. So my velocity is 36.77 t, and then here plus a 1/2. Now the rate of acceleration, gravity is pointing down, so it has to have a negative sign out in front of it. So negative 10 meters per second squared times time squared. So all of this I'm setting up to solve for time. So what I want to do is I want to get all my variables on one side of the equation and simplify. So in the end, this looks like 0 is equal to, this negative sign becomes a positive 50 plus 36.77t, and this simplifies to minus 5t squared. Awesome, I'm ready to solve, except it's a quadratic. So how do you solve a quadratic? Well, the easy way is with your calculator. You go over here and you set it up as an equation for y. So what we want to do for y is we want to plug in the equation just as we saw it. So here we set up, so 0 is equal to 50 plus 36.77, and here we just put in x for our variable even though it's t. The computer or the calculator, he doesn't care. And then minus 5x squared. Alright, so we put in our equation correctly, and now what we want to do is we want to graph that equation. And the calculator's thinking about it. Oh, there it is. And it comes back down. Alright, so like any quadratic, we have 2 points where it crosses the 0 line right here. One of them is in the negative side of the number line. So what does that mean? It means I went back in time. Well, that doesn't sound reasonable. So the one that's on the negative side, we're never going to use. Over here on the positive side, this is the value that we're looking for. So you can scroll over bunches of times, and this might take a minute. I already know the answer, but we'll just keep scrolling until we get to 8.51. Almost there. 8.48, close enough. All right, so that's where it crosses the line, is 8.48. So we come back over here, and we say t is equal to we're just going to round up, 8.5 seconds. So that's the time it took to go up, back through our original plane, and all the way down to the bottom. Now the last part is easy again. The change in x is just equal to my velocity in the x times the total time I was in the air. So 30.85 times 8.5 gives me somewhere in the neighborhood of 262 meters. All right, that was a good one.